Geologists can tell a lot about a rock through visual inspection in the field, but quantitative values of its different elemental constituents can be useful for determination of other aspects, including geochemical variations, presence of metals that cannot be seen by the naked eye, and if metals occur in economic quantities. So after a geologist collects a sample in the field, it will be taken to a local assay lab for analysis. But what happens after the sample is dropped off? When the sample is received by the lab, it is labeled, sometimes with a barcode, so that it can be easily tracked throughout the analytical process. Next, the sample is crushed until it is pulverized into a homogeneous powder. A portion of the sample is placed in an envelope and used for analysis. This is called the pulp. The remainder of the sample is called the reject, and it can be stored in case the geologist needs it for future analysis. Now the sample may be sent to the fire assay lab if the geologist is interested in its gold, silver, or platinum group element content. Fire assay, which is a term that comes from the early version of this method developed over hot fires centuries ago, uses a larger sample size than instrumental analysis. This way, a more representative measurement of the gold content can be determined. For fire assay, 30 to 50 grams of the sample pulp is combined with a mixture of other ingredients, called a flux, into a non-reactive ceramic container called a crucible. The composition may change depending on the sample, but it generally always includes lead oxide, called litharge. The crucible is then placed into a furnace, where a chemical reaction takes place. The lead melts to form small droplets. The droplets attract the precious metals, which are also molten, and the metals sink to the bottom of the crucible. After the mixture is removed from the furnace and allowed to cool, a solid piece remains with the lead button on the bottom and the remaining glassy material called slag on top. The lead button is separated from the slag and then undergoes further refinement called cupellation. During cupellation, the lead button is placed into a porous ceramic container called a cupel. The cupel is again heated, but this time in an oxidizing environment, so that as the lead button melts, the lead oxidizes and is soaked into the porous cupel, whereas the precious metals, which do not like to combine with other elements, remain behind as a small bead. Upon cooling, the bead can be weighed to determine its gold content, or it can undergo instrumental analysis to determine variations in precious metal content. We'll talk about a couple of these analyses in our next video.
Exploration is a complex process and can take up to 10 years. It requires significant time, financial resources, and expertise in several disciplines, such as geography and geology, chemistry and engineering. Only around 10% of global gold deposits contain sufficient gold to mine. Mining companies begin by investigating areas where the makeup of the local geology indicates the possible presence of gold. Often gold is found where there are concentrations of other minerals, such as copper or silver. Further investigative work will be carried out to determine the type and grade of minerals contained in the ore. Once more is known about the potential deposit and the local geology, the ore body can be modelled and its feasibility assessed. This may involve sophisticated computer programs, which not only help determine the size and structure of the ore body, but also the most efficient and economical way to mine it. The social and environmental impact of mining the ore body will be identified and addressed. Consultations with all stakeholders, including local communities and governments, will be conducted, and impact assessments will continue throughout the exploration phase.